This is a continuation of a previous video. So I'm going to do C and D now, and this is 1998 AB4, and I'm allowed to use a calculator for this. So at this point, I haven't actually used a calculator yet. You could have if you wanted to, but should have been able to get by without one. But anyway, part C says find f of x. So I want to actually solve for f of x by solving the differential equation, this thing, with the initial conditions of what I just pointed out over here on the left, so 1, 4. So I'm going to take dy dx, and I'm going to cross multiply. So that's going to give me here that 2y dy equals, when I multiply by the dx, I get 3x squared plus 1, close dx. And now it's set up for me to take the integral of. So I integrate this side, I integrate this side. When I do that integral, I get a y squared on the left side equals, the coefficients work out really nicely on this one, x cubed plus x. I need to make sure I don't forget my plus c. Remember, I only need the plus c on one side, and hopefully we've talked about that a little bit. But anyway, so now I'm going to, this is x equals 1 and y equals 4. So I'm going to plug those values in to solve for c. Maybe I'll underline this line because I'm going to come back to it. So when I plug those values in, I get 4 squared equals 1 cubed plus 1 plus c, which gives me 16. Equals 2 plus c, which tells me c is equal to 14. So from here, I am going to take this line, maybe I'm going to take those two lines and combine them, and I'm going to go and write that y squared equals, and so I'll stop for a moment here. Oftentimes, there's different opportunities to solve for c. I could have gone and solved for y, get the square root thing, and then plug my values in for c, but it would have been more complicated. So there's no golden rule about when to solve for c, and especially when we deal with ln integration and poked equations or whatever you want to call them. Then there's really different techniques. But in this case, I think that it's easiest to solve for c here, so that's why I did it there. So anyway, I go and I solve for, I'm going to plug that c value in. So I get x cubed plus x plus 14. Now I'm going to square root both sides, and I'll do this correctly. When I square root both sides, I get plus or minus x cubed plus x plus 14. My guess is that if you were doing this and you didn't realize the plus or minus, you would just not write anything and you would only consider the positive side. That's good for this problem because, notice, f of 1 is equal to 4, right? So f of 1 is a positive 4. So f of 1 equals 4. So what I'm trying to point out here is that if I plug in 1 for these two values, I get the square root of 16, which gives me 4 out if I take the plus side. If they had given me f of 4 was negative 1, I would have had to make sure I catch that negative sign. They'll often do that. Like, I've seen it on multiple choice questions before. Probably some FRQs. But anyway, so you should consider that, although in this particular problem, if you didn't write the plus or minus and you only wrote then you're good to go. And that's what my f of x is equal to. So I think, let's see, that is the answer to part C. Box it. And then now they want me to use my solution to find, for part C, to find the value of f of 1.2. So this, I'm just going to plug it into my calculator. I'm going to plug in f of 1.2 equals square root of 1.22 cubed plus 1.2 plus 14. Plug it in my calculator, hit enter, I get 4.114. And that's my answer for that guy. So part D is a little bit quicker. And I think they want us to do that so that we can compare. Oh, I don't have it anymore. In the other video, we found, for part B, we found an approximation, and it was 4.1. So that's pretty close. That's all.